Microplastic pollution levels in Connecticut waterways have evolved over recent decades. These microplastics have had profound impacts on aquatic systems. Microplastics are plastic fragments smaller than 5 millimeters. They are a defining marker of the Anthropocene era due to their presence in this environment. This issue is a representation of our reliance on plastics and the challenges our aquatic ecosystems now face. The microplastic pollution in Connecticut waterways have increased significantly over the past couple decades, mostly driven by industrial activities, urban runoff, and certain improper disposal of waste. Pollution of this type poses serious threats to certain aquatic organisms. Things like habitat disruption and toxic chemical accumulation are some to note. There are plenty of historical and current levels of microplastic pollution, and over the past 30 years, microplastic levels in Connecticut's rivers and waters have risen quite a bit due to the use of synthetic materials. In Michaela Savit's article, she talks about a report, and it states that over 6 years, more than 82,000 tiny pieces of plastic and over 54,000 food wrappers were found in Connecticut waters. These microplastics also don't just affect animals. The Anthropogenic Markers curriculum states that 39,000 to 52,000 particles per year are consumed by a person in North America. And this shows that microplastics are more of a general, very dangerous, hazardous substance that affects everything in an ecosystem and not just the animals and habitats. There is evidence of microplastic accumulation right near Yukon. To understand local impacts, some water sample has been collected from Mirror Lake, which is right near the University of Connecticut, and these revealed alarming levels of microplastics. Analysis of these samples showed a prevalence of microfibers, and they likely originate from campus laundry facilities and some urban runoff. Additionally, some studies near Long Island Sound identified microplastic hotspots where some of the particles accumulate due to tidal and current patterns. And these findings kind of underscore the nature of this pollution. And even in seemingly pristine environments, it's still possible for microplastics to invade and harm organisms in the surrounding areas. This picture is ripped straight out of Unit 17 of our textbook, and it shows a fishery in the New England region that is affected by pollution. Fisheries tend to be a common spot for pollution as it's on the coastal line, and it's where a lot of micro pollution can occur. This directly correlates with impacts on aquatic ecosystems. And some of these impacts are things like being ingested by organisms, which is very dangerous because small organisms mistake these microplastics for food, and this can reduce reproduction and bioaccumulation and just general deathly habits for these organisms. And a good example of this is studies in the Connecticut River have documented that the microplastic ingestion of fish species like trout and bass have been much higher in the past couple decades compared to earlier, around the 1960s and 70s. In the Anthropogenic Marker lecture, What's So Micro About Plastics, they list off some of the issues of microplastics that have affected rivers in the areas around Yukon and in Connecticut. One of these is chemical leaching, and this is when microplastics have harmful chemicals like heavy metals in them that, when ingested, can impair metabolic and reproductive functions in aquatic life, especially certain types of fish that are local to the areas in Connecticut. This can give heavy damage to biodiversity in certain areas and cause the extinction for certain fish species if gone too far. Here's a food chain I created to show the microplastics and how they travel. So, first we start with the actual plastics themselves, cups, bottles, stuff like that. They end up going to the ocean and decaying. And once they decay slightly, they can slowly become microplastics, which are less than 5 millimeters, very small, and very easy to reach plankton and other fish. But usually what happens is the plankton eats or consumes these microplastics, which then goes directly to the fish because the fish eat the zooplankton. And then after that happens, the fish typically contains microplastics in them for a long period of time, affecting their reproductive health or other issues, and they can be caught by fisheries and eventually fed to humans, and that's how some forms of microplastics can get to humans and actually cause hazardous problems. And this is an issue that can occur with a lot of Connecticut waterways. These issues with microplastics in Connecticut reflect a larger systematic challenge, and to address this pollution, we need both policy and personal action to be done. There needs to be certain initiatives, like expanding regulations and water acts to limit other plastic pollutions. Infrastructure improvements can also help upgrade wastewater treatment facilities and filter these microplastics. And last but not least, individual actions must be taken place, because if we all individually help, we can reduce reliance on single-use plastics and support these innovations in a biodegradable material supplement. As we see, microplastic pollution levels have changed heavily in Connecticut's waterways and have gotten much worse. And they also have a lot of negative impacts on these aquatic systems that we just covered. However, now that we understand these sources and the impacts of this type of pollution, we can take the meaningful steps it takes to mitigate the effects and protect our waterways for future generations. We need to work together and ensure that our state's rivers, lakes, marine environments, and any other body of water around this area remain very healthy.